What are the possible mechanisms by which something from outside the solar system, so beyond the Oort cloud, might come to live here with us? And I'm guessing that there's gravitational capture, and then collisions might also function in conjunction with the gravitational capture, but I'm not sure what else there might be.
Not much. So let's maybe
Decelerating
like
spacecraft.
that's right. Yeah, exactly. But let's start off with the, I think, kind of zeroth order question of, should we expect that there are extrasolar rocks floating through the solar system? Like, is that a crazy notion to begin with? Right. And the answer is absolutely not. Right. Like, meaning absolutely it's not crazy. It is a given that there has to be extrasolar material, in flux through the solar system. This is not controversial. The solar system itself ejected something like 20 Earth masses of icy debris during the first kind of 60 million years of its lifetime. And, well, where did they go? They now float around through the galaxy, occasionally coming into kind of contact with other planetary systems. And other planetary systems did the same. Right? We now understand that early instabilities among planets are pretty common, and it's common to eject material. And so it comes as no surprise that extrasolar material exists. To this end, Comet Borisov, which came after Oumuamua, about a year and a half, came and transited the solar system, also on a hyperbolic orbit. It was an extrasolar comet, was perfectly normal. I mean, when there were spectroscopic measurements of it, there were things about it that clearly were not, identically solar, but, it was a regular piece of, ice that was floating from from some other solar system that came and passed in our kind of cosmic neighborhood. So it's a totally normal, process to consider. Now, the process of actually capturing something onto a bound orbit within the solar system, that's very, very challenging. Okay, that's, at the end of the day, the amount of material you can challenge is really, really quite small. Right? I forget the exact number, but I think it's like on the order of the mass of Mount Everest or something that you can capture through, over the lifetime of the solar system through just gravitational capture. And then you say, well, are there other processes? Well, early on in the solar system's lifetime, within the first few million years, yes, there's gas drag that can help you decelerate and all that. But there's not really much beyond that.
Yeah. Space is pretty rarefied in our neighborhood right now.
It sure is, yeah.
Yeah.
So disappointing how little things there are.
Yeah. Mm-hmm. Something though that I guess relates to how little things there are, but that occurred to me as you were responding is you said it's quite common to eject material. In the first 60 million years, we ejected 20 Earth masses of icy debris, and I'm wondering then. You said it's pretty rare that those will come into contact with another planetary system because of the vastness of space. But is it then always? And I'm getting ahead of myself with regard to the planetary with the solar system dynamics. But is it always a distinct possibility, though small, that some super Earth could come into our solar system from another planetary system and then disturb our orbit and send us careening into the sun or out of the solar system entirely?
I mean, sure. And you can do the calculation, right? You can do the calculation to demonstrate the odds of that, right? Now, the odds of that are negligibly small for timescales that we're interested in. But if you're willing to wait sort of 100 billion years. So kind of, 20 times the age of the solar system. Then that process of passing stars, even, right, just random passing stars, that becomes an important perturbation for the solar system itself. Right? So eventually, the solar system will get completely disrupted by virtue of passing stars coming close enough to the orbit of Jupiter to just eject all the planets, and the sun will be alone. Right? That is a fact. And it's a little depressing for when that happens, but all good things come to an end, including the solar system.
No, it's terrifying though, because even though it's of, as you said, negligible probability within our timescales, we're always worried about a direct impact from a fairly small asteroid, but there are things large enough that they don't even have to come anywhere near us to cause serious existential problems for Earthlings. But okay, so you have made it abundantly clear that there's almost certainly masses from outside the solar system in our solar system, but it seems that there's been some controversy over whether there is evidence for any particular interlopers in our neighborhood. So what are the arguments for this, and then where do you stand on the matter? And yeah.
I really don't think much about it, to be honest. I mean, if I were to summarize, if I was to summarize, look, like, are Oumuamua and Comet Borisov robustly hyperbolic and extrasolar? Absolutely, right? No doubt about it. Is it a huge surprise? No, right? There should be extrasolar material constantly transiting through the solar system. There's a little bit of tension, I would argue, with the amount of mass that you require, just like in the galaxy. It's not a humongous tension, but it's a little bit on the upper end of how much you require each star to eject to explain these data. But, again, it's small number statistics for the time being. So all of this is completely normal, right? Is there evidence that this is like alien spaceships? I'm
sorry if my question was unclear. I wasn't asking if there were alien. I just meant, is there evidence that there are interstellar objects residing in our solar system, not just passing through? That's what I was asking.
Residing
Do we have
in
evidence
our solar
for
system?
particulars? Yeah.
Okay, great question.
That's what I was saying was
don't.
controversial. For the record, I don't think that there are aliens in our solar system, and I wasn't trying to suggest that.
Yeah, it's a bummer because I keep waiting. I keep waiting to encounter some. But look, the question of like, could there have been extrasolar meteorites that have fallen on the Earth is not fundamentally like a bad question. It's a perfectly good question. The way you do that is you go and you date them, and you try to find material that's older than 4.5 billion years. Right? If you find rocks that are robustly older than the sun, right? They must have come from some extrasolar source. And I think Joe Kirshnick at Caltech spent some time trying to do that. Right? Just trying to find extrasolar meteorites that are older. Didn't find any, but it's not impossible that they exist. There's no evidence that they exist yet, but yeah, it's a reasonable thing to ponder.